Okay, welcome to another marathon video. Today's topic is O-level math algebra. Remember that I am doing these questions without the help of a calculator, so make sure that you do them accordingly. Um, if you wish to download the unsolved worksheet and the solved worksheet, there will be links in the description. Please make sure to go into the description and find the worksheets and solve them yourself as well. Okay, beginning with the questions. Question number one says factorize. So this is a question on breaking the middle term. I'm trying to factorize a quadratic um, expression. Now, in the lecture videos, I've shown you that when you have a simple x square, you don't need to do much. You just need to think about the factors of 12. You start thinking about the factors of 12, and you say that 12 can be broken up into 1 into 12, or 2 into 6, or 3 into 4. And I need a pair that when added and subtracted will give me this middle term, and when multiplied will give me that plus 12 that I had, because there was a 1 here in any case. So what I'm going to do is I'm going to say that I'm going to pick up 3 and 4 and say that this is x squared minus 3x minus 4x. Because I need a minus 7, I will have to decide the signs myself. I cannot take the signs on the go. uh, I will have to decide them based on the numbers that I have. So plus 12. Then I make them into pairs and factorize. The common term in the first two is x, so I write x minus 3 and minus 4 in the next two terms. So I take the minus 4 common and I have x minus 3. Now the important part in these questions is to note that this bracket must match with this bracket. If they match, they can be again taken out as common, and what I've left from this term is an x. Okay, so I write that, and I'm left with a minus 4, so I write that. So I factorized this first expression for you. That's part A. So I'm going to write x minus 3 into x minus 4. Okay. Then part B, solve x plus 1 into 3x minus 2. Now this is already a factorized expression, and I have 0 on the other side, which means that I can simply go on and do either this equals to 0 or that equals to 0. Okay. So x is therefore equals to minus 1, or 3x is equals to 2. And when I take 3 to the other side, it goes into divide, so x is either 1 or 2 over 3. Okay. Then question number 2 says expand and simplify. So in this case, what I have to do is I have to multiply x with the entire bracket and then minus 1 with the entire bracket. So what I'm going to do is I'm going to write x into x squared plus x plus 1, and then minus 1 into x squared plus x plus 1. What that gives me is x cubed plus x squared plus x minus x squared minus x and minus 1. I first multiplied x with all of these, and I got these three terms, and then I multiplied minus 1 with all of these and got these three terms. So I get a total of x cubed. The plus x squared and the minus x squared will cancel out. The plus x will minus x will also cancel out, and I'm left with x cubed minus 1. So a very simple expression for a very long expansion. Then this question says factorize. So I know that when I have four terms, this is a question on factorizing by pairing. That's what we've covered in the lecture. So I take an x common and I say this is a minus b, and then I say that what is common? Minus 3y seems common. So I'm again left with a minus b. So again, the same idea that these two brackets must match. So when these two brackets match, I pull that out common, and from the first term set of terms I'm left with x, and the second set of terms I'm left with minus 3y. So that is the factorized form. That was question number 2. Let's go on to question number 3. It looks different. and shows a diagram as well. Let's not get worried about the diagram. It's probably an algebra question that has just values. Okay, so let's talk about this. It says two vertical posts at the same height on horizontal ground. The distance between the posts is d centimeters when a wire of length w centimeters is suspended between the posts. The sag in the middle is s centimeters. So the sag is basically how much it's sort of, bent down or dipped a little. So that's the sag, and it's represented with an S. The sag is given by the formula this. They've given you the formula. Just find S when D equals to 800 and W equals to 803. So I'm getting 3 into 800 into 803 minus 800 over 8. And the entire thing is in a root. So I get 3 into 800 into another 3 divided by 8. So I can do this, and I can say that this is 9 into 100. I need to take a root, so the root of 9 is 3 and root of 100 is 10. So 3 into 10 gives me 30. It's a simple calculation question. Then it says W in terms of DNS. So I need to construct a formula for W. So I'm going to first write this expression, and my objective is to isolate W out of this. So I'm gradually going to remove the things that I can remove. First, I'm going to remove this root because I cannot handle W with the root. So S square. Then I see an 8 at the bottom. So I'm going to cross multiply that and say that this becomes 8S squared. I also don't need the 3D, so that comes down in the denominator and I get 3D. And then I can say that 8S squared over 3D plus D equals to W. Now you might say that this does not match with the answer option. The marking scheme says that this should be the final answer, but it will also say OE, which means or equivalent expression. So this is an equivalent expression, and that's a perfectly fine answer to write. Write 8S squared plus D, and this is over 3D. If you notice, if I take a common denominator, I'm going to end up with the same answer. Okay, question number 4 says express as a single fraction in its simplest form. So I need to take a common denominator in this case. I'm going to say that the common denominator is x minus 3 into x plus 2. Both the brackets multiplied together. Now this 2 is going to get multiplied with whatever was absent in the denominator. I'm going to say that x plus 2 is absent in the denominator, and 1 is going to get multiplied with x minus 3 because x minus 3 was absent from its denominator. So I get 2x plus 4 minus x plus 3, and keep the denominator as it is. I don't need to expand this. The objective is to just get you the simplest form, and it's best to just keep it that way. Sometimes it cancels out. So x plus 7. So that is the simplest form that I have. I'll write x plus 7 over x minus 3x plus 2. The next question says solve the equation. This is an equation, so I need to find the values of x. So what I'm going to do is I'm going to cross multiply and say that I get 3 into 4 is 12 and x minus 1 into x plus 3. Now remember that you cannot do this right now. You cannot say that either this equals to 12 or that equals to 12. That is wrong. You can only do that when you have an equals to on the other side. So what I will have to do is I will have to expand this. I will have to first multiply this bracket out and say that this is x squared plus 3x minus x minus 3 equals to 12. So 0 equals to x squared plus 2x minus 3 minus 12. X squared plus 2x minus 15. Now this has turned into a quadratic equation. I will have to factorize this and solve or use the quadratic formula, but paper 1 I don't have a calculator, so I'm going to not try to not use the quadratic formula. Okay, in order to solve this quadratic equation, I am going to break the middle term. So what numbers do I have to think about? The factors of 15. So 1 into 15, 2 into is nothing. Okay, that can't happen. Sorry. And then I have 3 into 5. So I want a factor set of numbers that gives me minus plus 2 in the middle. So yes, I can think of those numbers. I can say that this is plus 5x minus 3x minus 15. What is common in the first two numbers? It's x plus 5. X is common, so I'm left with x plus 5. In the other two numbers, I have minus 3 common, so I'm again left with x plus 5. So x plus 5 and then x minus 3 gives me, and this is equals to 0, so I'm going to say that either this equals to 0 or that equals to 0. Minus 5 and 3. Okay, then question number 6 says factorize completely. So the first thing when you're doing factorizing is to note if there's something common. I can see something common. I can see 5 common, so I get a square minus 4. Then I see that this is that factorization where I have a difference of squares. So a square is the square of a and 4 is the square of 2. So I can break it up into two factors and I can say that this is a minus 2 into a plus 2. That is the complete factorization of 5a square minus 20. Then it says a formula connecting x and y is this, where k is a constant given that y equals to minus 1 when x equals to 2. Okay, this is probably B part 1. So y equals to k over x cube. I can use x as 2 and y as minus 1. So that gives me k over 8. So k equals to minus 8. Then it says find x when y equals to 64. So now I have minus 8 over x cube. I have y as 64. Okay, so if I cross multiply this, I get 64 x cube equals to minus 8, and then x cube equals to minus 8 over 64, which is 8 times 1 and 8 times 8. So x cube equals to minus 1 over 8. How do I remove a cube? I take a cube root. What's the cube root of minus 1 over 8? Minus 1 has a cube root minus 1, and 8 has a cube root of 2. So I get minus 1 over 2. Then question number 7. Again, I have 4 terms, so this is probably factorizing by pairing. Let's see if I can make pairs and take something common. Okay, part A. 3tx minus 2sx plus 15ty minus 10sy. So x is common, so 3t minus 2s. 5, 15 and 10 and y is common, so it's 5, 3, 5y basically, 5y. So 3t and 2s. I told you before that these brackets must match, so they match. So I can say that one of the brackets is 3t minus 2s is common, and I'm left with x from the first term and 5y from the next term. Okay, part B says x minus 2 over 4 plus x plus 1 over 3. So I take a common denominator. 3 into 4 is 12. 3 and 4 don't have any common factors, so I don't have to worry about a lot. This is going to get multiplied by 3 and this is going to get multiplied by 4, so I'm going to write 3 times x minus 2 plus 4 times x plus 1. So 3x minus 6, 4x plus 4, and that 12 gets cross multiplied equals to 12. So I get 7x equals to 12 plus 6 minus 4. 7x equals to 14. X equals to 14 divided by 7, which is 2. Then part C says factorize. This is a quadratic expression with 3 terms, so I have to break the middle term. Now, in these questions where the coefficient of your square is not 1, what you need to first do is you need to multiply these two numbers together and see what you get. You multiply minus 2 by 2, the third term by the first term, and you say that the number that is coming up is minus 4. What are the factors of 4? 1, 4, and 2 and 2. So which ones am I going to use? I'm going to use the first set of factors, and I'm going to say that this is minus 4y plus 1y minus 2. What is common? 2y. So I'm left with y minus 2. Since the last two terms don't have anything in common, I'm just going to say that 1 is common, so y minus 2. So what am I getting? I am getting y minus 2 as the first factor and 2y plus 1 as the second factor. Okay, question number 8 says given that x equals to 6 is a solution, so whenever you have a solution, you can simply do is what you can simply do is you could plug in the number instead of x and find out the solution. So that's what I'm doing in the first part. I've written 6 squared over 3, so that's 36 over 3 plus k equals to 0, k equals to minus 12. In part B, again, it's a quadratic equation. It looks more or less similar to the previous one, I think. Yeah, it's exactly the same, in fact. It's surprising. So I think I'm just going to write that answer instead of trying to solve it again. This time, oh, it's equals to 0, so it's slightly different. I just don't have to factorize this. I'm going to have to find the values of y as well. So I'm going to follow the same method. I'm going to multiply 2 and minus 2 together and make the factor minus 4, factors of minus 4. So it's again 1 into 4 and 2 into 2. I'm going to do that plus y minus 2. So the first two terms have 2y common, so I'm left with y minus 2, then plus 1 common, y minus 2. So y minus 2 and 2y plus 1. And this is equals to 0 this time. This is an equation, so I'm going to go on and say that either this equals to 0 or that equals to 0. So y equals to 2 or y equals to minus half. Okay, it was minus 12, 2 and minus half. Question number 9 is simple. It says just is factorize. So I'm just going to go on and factorize. There's nothing unusual about it. It simply becomes x plus y into x minus y. This is the difference of squares, and we've done a lot of questions in the lecture series. So that is the answer to that. Let's solve the second part. It says evaluate this. So again, I see a difference of squares. Now, the surprising thing about these questions is you can solve them with a plus b into a minus b. Okay, in the same way that you did it for algebra, you can do it for numbers as well. And you get 102 minus 98 into 102 plus 98. That's 4, and that's 200. I get a total of 800. 4 into 200 is 800. So these are calculation tricks that you should be able to do on the exam as well. Question number 10 is very different. Let's try solving that. It says given that n is an integer and n is greater than 1, decide whether each statement in the table is true or false for each statement. Give true or false on the table. If you write false, give an example to justify your decision. Okay, so if n is greater than 1, the cube of that number will obviously be greater than 1. When negative numbers are cubed, they give you negative numbers, so this is true. There's no need to give an explanation for this. Okay, 1 over n is greater than n squared. The simple thing that I could do here is cross multiply this, because they're positive numbers. I could say that then n squared is greater than n. Would that be true? Yes, obviously that would be true, because if I take a number greater than 1 and square it, it's definitely going to be greater than the original number that I have. n minus 1 into n plus 3 is always odd. Now you get odd numbers when two odd numbers are multiplying together. That's the only way that you can end up with an odd number. Okay, so for that case, n minus 1 must also be odd and n plus 3 must also be odd. So it's not necessary n could be 2. If n is 2, this could be 5 and this could be 1. In that case, I would end up with an odd number. But what if n is 3? Then I would end up with 2 into 6, which is 12. So it's not odd. So I can just say that it's not always true, which means that it is false. Okay, what example am I going to give? I'm going to give you this example only, that I've plugged in n equals to 3 and said that this becomes 2 into 6, which is 12. You could pick up any other example if you wanted. You could essentially pick up a decimal number. No, it says integers, so you have to pick up integers. Okay. Then question number 11 says factorize completely. So 3x squared minus 12x. The first thing that I should always do when I'm trying to factorize is to think of common numbers. So I'm going to factor out 3x and say that I'm left with x minus 4. So that's the complete factorization of this. Then part 2 says x squared minus xy minus 2y squared. Now you must notice that although there are two variables, this is again an example of a quadratic expression, and it's going to be factorized in the same way that you factorize a quadratic expression. I'm going to use the same um, breaking the middle term idea and do this. So I'm going to say that the numbers that I have are minus 2 and 1. So I have the factors of minus 2, those are simply 1 into 2, no other factors. So I'm going to have to arrange those only. I'm going to say that x squared minus 2xy plus xy. You see, I've broken the middle term into two components. Why have I done that? So that I could then take out a common. Okay. What do I see common in the first two terms? I see an x common in the first two terms. So I'm going to say that this is left. I'm left with x minus y, x minus 2y. I'm sure you can see that y is common in the next two terms. So again, I'm left with x minus 2y. So I have x minus 2y and x plus y. Then it says part B, simplify. Simplify means you have to make sure that if there's the things canceling out, you go ahead and cancel them. So what is common in the numerator? I see that x is common, so I'm left with x plus 4. What is common in the denominator? I see a difference of squares. Can I factorize this and say that this becomes x minus 4 into x plus 4? I see the square of a number and I see the square of another number, so I can factorize this. What that helps me do is it helps me cancel out x over x minus 4. Okay, let's talk about question number 12. It says factorize fully. So the first thing that I do is I see if there's something common. Yes, I can see that 10 and 15 have a common factor 5. I see an x common and a y common as well. So 5, x, y, I'm left with 2, and I'm left with x, and I'm left with 3, and I'm left with y. So I think that's the most factorization that I could do with this expression. Then there aren't three terms, I couldn't break the middle term and so on. So that is it. Then I see the next one. I don't see anything common, but I see both being squared. So this is a difference of squares. So I'm going to say that this is basically 25 is the square of 5. So this is 5a minus b into 5a plus b. Then part C. This is asking me to simplify a complicated fraction. Now I need to think about the common denominator here. Now remember that when you have repeated brackets, you don't multiply them together. You won't write x plus 1 square into x plus 1. You have to tell me the common denominator, which means that you have to tell me the lowest common multiple, or the LCM. So if these brackets are being repeated, you just take the highest power. Okay, and the process there is in the lectures. You can go back and look at the lectures. Okay, x plus 1 whole square. So this is going to get multiplied with nothing, just 1. 3 times 1. Why? Because the entire thing is in its denominator. What about the second one? It has 1 power missing in the denominator, so I'm going to multiply it with the bracket 2x plus 1, because its denominator just had x plus 1 power 1. The common denominator has a power x plus 1 power 2. I get 3 minus 2x minus 2. Yeah, I think that is the final answer. Okay, then I think D is simple. When you change the divide sign into multiply, you need to take the reciprocal of the second term. So I'm going to take a reciprocal and say that this is 5b squared c over 9a. Let's see what cancels out. C cancels out with c, 3 cancels out with 3, 5 and 2. Now I have a, so I can cancel out power 1, and I have b, I cancel out power 1 as well. So I'm left with a into b over 6. Okay, I hope that was simple. Question number 13 says make y the subject of the formula, so I'm going to cross multiply and say that y into 3 minus a equals to a minus 4. Now, if I want to make a the subject of the formula, I will have to gather all the a terms. So first I'll have to multiply them. So 3y equals to 3y plus 4 equals to a plus ay. Can I factor out an a? And I get this. So a, 3y plus 4 divided by 1 plus y. Okay, question number 14 is then the first part says given that this, find the values of a and b. This question is about completing the square. Now we've learned the process of completing the square. So what I am going to do is I'm going to try to replicate that process. I'm going to say that x square minus 14x plus 40 has to be closed into a bracket that says x minus a whole square. So I'm going to start breaking, and I'm going to say that I have a square. I want to close that into a bracket, so I'm remembering my identity that I've learned, a square minus 2ab plus b squared. So I'm going to write 2 times a, the first term, squared. Now what other term should I have here? If I want 14 in the middle, I'm going to say that I need a 7 here. And if I want to close this bracket, I should have a 7 squared here as well. So I get a plus 7 squared. So I know that these terms together will be going inside a bracket. Okay, but since I added the 7 square myself, what should I do? I should add a minus 7 square as well and write plus 40. So I've written all the terms down. Now what do? I know that these three bracket terms will close down into a bracket that says x minus 7 whole square and minus 49 plus 40. That gives me x minus 7 whole square minus 9. So what is the value of a? You can see that the minus is there, so a is the number after the minus sign, so that's 7. And what is b? B is the term outside, so b is minus 9. There are other ways of completing the square as well. I hope you will be able to watch the lecture videos for that. Okay, this is solve by factorization, so I'm going to write 3x squared plus 7x minus 6. You multiply 6 with 3. and you get 18. 1 into 18, 2 into 9, sorry, minus 18, 2 into 9, 3 into 6. So I need a pair of factors that will give me 7 in the middle. So I'm going to pick up these set of numbers. I'm going to say that I have 3x squared plus 9x minus 2x. So 9 and 2 give me 7. What is common in the first two terms? 3x. So I'm left with x plus 3. Then minus 2 common, and I'm left with again x plus 3. I get x plus 3 and 3x minus 2. So either x plus 3 equals to 0, this is equals to 0, or 3x minus 2 equals to 0. X equals to minus 3, or x equals to 2 over 3x equals to 2, and x equals to 2 over 3. Moving on to the next question. As a single fraction, so I need to take a common denominator. The denominator here is 1, so there's nothing common in the denominator, so I'm just going to multiply all of them across. What was missing in the first one? It was missing one was missing an x plus 1 in the denominator. It just had an x in the denominator, so I'm going to multiply 1 with x plus 1. 2 was missing the x, and it was also missing the x plus 1 in its denominator. Its denominator was only 1. Okay, so it was missing both x and x plus 1. And what do I multiply 3 with? I multiply 3 with whatever it is missing in the denominator, and it's missing out an x in the denominator, which is there in the LCM that you've taken. Plus 2x. So 2x squared plus 3x minus 3x plus 1. Okay, moving on. Question number 16 is again about factorization. This looks like simple. I have to think about numbers that will give me minus 5 in the middle and plus 6 at the end. So 1 into 6, 2 into 3. I could use actually both 1 and 6 and 2 and 3, but I'm going to use 2 and 3 because the signs have to be arranged in such a way that they give you minus 5 and a plus 6 when multiplied together. Okay, if I was to take plus 6 and minus 1, that would give me minus 6 when multiplied together. I don't want to minus 6. I know that my last term is just plus 6, so I just need a plus 6. So x and then x minus 2 minus 3 and then x minus 2. I factorized by pairing. I have the same bracket, so I can say that this is x minus 2 into x minus 3. Then it says given that x equals to 4 is the solution. So I know that whenever I have a solution, I can plug it back in and find whatever is missing. Okay, I think that was simple. Look at the next one. It says remove the brackets and simplify. I think that's simple too. 4 times 7x is 28x minus 12 minus 15x plus 12. So that gives me just 13x. 12 and 12 cancel out. Express as a single fraction. Okay, so what do I see is common in the denominator? That's going to come up only once. So my LCM will not be 12y squared, it's just going to be 12y because y is common in both the fractions. Okay, what do I multiply this with? Now this had a denominator of 3y. Overall the denominator was 12y. So I'm going to say that this should be multiplied with a 4 because in order to make 3y equals to 12y, so 3y is missing a multiply by 4 in the denominator, so that's what I'm doing. And this is missing a multiply by 3. So 16 minus 15, 1 over 12. Okay. Then I think multiplication is simple. You multiply with the numbers with the numbers. So 12, you multiply 8 with a, so a square into a is a cube, and b into b cube is b power 4. Okay, and that was it about this question. Question number 18, it says 20b plus 25b squared. Okay, question 18 says factorize. So what's common in these two? I see a 4 common, no, sorry, a 5 common between 20 and 25, and I see a p common. So I'm left with 4 here. 20p divided by 5p is 4, and 5p squared divided by 5, 25p squared divided by 5p will be 5p. So 5p into 4 plus 5p. Now I just see two terms. There's nothing common about them, but I see square numbers. So 9 is the square of 3 and 40 is the square of 2t. So I'm going to say that this is the difference of squares, 3 minus 2t into 3 plus 2t. Okay, then I see a quadratic and it's weirdly written, so I'm going to first write it in the form that it's supposed to be written, although I can do it in the other way as well. Okay, so what I need is I need the factors of 9 into minus 4. I need the factors of minus 36, and I need them in such a way that it generates a 35x in the middle. I'm going to say that 36 just has 1 into 36, so and then 2 into 18, and 3 into 12, 4 into 9, and 6 into 6. But I don't need all of these actually. I just needed 35. I know that this is the only number that can generate a 35, so I'm going to write it properly here. Say that I have 36x minus x plus 9. What is common in the first two? Minus 4x. So I'm left with x minus 9. And then the next two terms, in order to make that bracket same, I'll factor out a minus 1, so that this bracket also becomes x minus 9. So x minus 9 and minus 4x minus 1. Okay, and that's a perfectly fine answer. You don't need to worry about this. So what you've done is taken the minus common and put it with the other number. So you can do that too if you want, but that's not necessary as such. Question number 19 is just about making x the subject. I think we just did a question like this. Let's do this quickly. You square both sides first to get rid of the root. You get 16 equals to cx plus 1 over dx minus 1. So cross multiplying, then 16 dx minus 16 equals to cx plus 1. I want to make x the subject, so I'm going to gather the x terms on one side and factor that out. So then it goes into the division. Okay, then question number 20. 10 minus 9x plus 6. I just expanded. I think it's a simple question. 16 minus 9x. But we say simplify, so I'll have to factorize both, see what cancels out. I can obviously see in the denominator that the denominator is a difference of squares. So 9x squared is a square of 3x. So this becomes 3x minus 1 into 3x plus 1 in the denominator. The numerator has a quadratic expression, so I'm going to have to do that working that I do for breaking the middle term. So I'm breaking out 15. That's 1 into 15, and I think that gives me 16. So I don't really need to make more factors. That's 3 into 5. I'm just going to say that 3x squared plus 1 plus 1x plus 15x plus 5. So what's common in the first two? 3x. What's common in the other two? 5. So what that helps me do is it helps me cancel out a bracket in the denominator. You see, In the numerator, I have a bracket common as 3x plus 1, and the leftover terms are x plus 5. This 3x plus 1 will cancel out with this 3x plus 1. X plus 5 over 3x minus 1. Okay. That brings us to the end of this worksheet. Please make sure to like and subscribe, and there are links in the description for you to practice if you want. I will see you with another video with Algebra Marathon from paper 2. Thank you for watching.